In this quick video, we will look at how to run SDN controllers in Mininet other than the default controller. If you are not already familiar with Mininet, I recommend watching my Introduction to Mininet video on my YouTube channel, or going to mininet.org for full details. So here is a diagram of the basic Mininet topology that is launched when you simply run sudo mn. By default, Mininet launches the OpenFlow reference controller, so that's what C0 will be here. However, we probably really want to be able to run a different SDN controller of our choosing. So let's look at an easy way to do that. Here I have an SSH session into a Mininet VM. So when I run sudo mn, I just end up with the default controller. If I run dump here, I can see I have my controllers C0 and OVS controller, and it's running at 127.0.0.1, the loopback 0 interface, and over TCP port 6633. So I'll exit this topology because I actually do not want to run the default controller. So I'll exit, and I'll also clean up my emulation by running sudo mn-c, which you should always do when you finish a emulation session. Let's now instead run a different controller. In this first example, let's just run our controller locally on the same VM we are running Mininet on. Here now on the right I have a second SSH session open into the same Mininet VM. I previously installed Floodlight to use as my SDN controller. Details on installing and using Floodlight can be found from www.projectfloodlight.org. So I'll run the Floodlight controller. Floodlight is Java based, so I'm going to run java-jar target/floodlight.jar, and we'll give that a minute to start up. And we see it starting okay, and we see that it is listening for a switch on port 6633. Now all I have to do is run Mininet with the controller option. So it's sudo mn again, but this time I'm going to say --controller equals remote. In this first example, I'm not going to give it any further options because the default, it's going to do an IP address of 127.0.0.1 and try to connect on a TCP port of 6633. So I didn't have to provide those details in that controller option. A bit funny that I'm saying the controller is quote-unquote remote. It's just that it's remote in the sense that it's outside of the Mininet program at the moment. So over here in Floodlight on the same VM again, you can see my single OpenFlow switch is connected. We see its data path ID or DPID is connected here, showing the DPID here and showing it's connected. So let's verify if my SDN controller is working properly. So over in Mininet again, I'll do the ping all command. And we can see that yes, my two hosts H1 and H2 can both reach each other. So the controller must be working okay. Let's stop Floodlight with Control-C. And just to verify, we'll do ping all again in Mininet. And we see it looks like we're going to get a timeout. H1 is unable to reach H2, and that's expected because we've now killed our SDN controller session. Let's clean everything up again. So I'll do sudo mn-c, I exited out of my Mininet session. And I'll exit out of my Floodlight session here. And I'll close this SSH session. Now let's try running a controller that is not on the same VM I'm running Mininet on. So I have another VM running here now, aptly named another VM. On this VM, to change it up, I'll run the POX SDN controller instead of the Floodlight controller like before. POX is Python based, unlike Floodlight, which was Java based. By the way, if you're using a Mininet VM you downloaded from mininet.org, POX is already included. So for my POX directory, I'll run python./pox.py forwarding.l2 learning. That will start POX with the basic layer 2 forwarding switch for the controller. Now I'll run Mininet again. This time I'll need to specify the remote IP because it's no longer 127.0.0.1. So I'll run sudo mn-controller again equals remote, and this time I'll say IP equals 10.0.0.12. And I'll also specify the port of 6633. Actually, I don't have to do that because the default is 6633, but I just wanted to show that that option exists, that it's there. So let's run it, and right away I can see my Mininet switch S1 has connected. There's its data path ID, and we see it is connected. And in Mininet we'll verify again. We'll do it a little different way this time. I'll do H1 ping H2, and we can see the ping session working just fine. So now I'll come over to POX and I can kill it with Control-C. Now this is a bit interesting. I have no controller running at the moment, so why do my pings still work? The answer is that flows are cached on the OpenFlow enabled switch. So the POX controller has sent the switch a flow modification message, which resulted in flow entries on the switch. These entries are cached until a timeout expires. In this case, I have active packets going, so they will work until a hard timeout expires, and it looks like we have just expired now. So once that hard timeout expires, and you see, yeah, they are timing out now, they will stop working because there is no SDN controller running. If you are brand new to OpenFlow, I'd suggest watching my Introduction to OpenFlow video, which will explain more details on this. So that's it for that pretty brief video. I can be found, as always, on LinkedIn at www.linkedin.com/in/David Mahler. In the video description, I also put a link to a blog entry on mininet.org that shows some other ways to launch SDN controllers, like through a Python script or within an mn command. I hope you found this short video helpful in using remote SDN controllers in Mininet.